Hi, this is a tutorial for the D programming language. In the previous tutorial we implemented a small guess the random number game, and we didn't quite finish because there's currently no way to lose the game. So today we are going to implement failing the game, and we'll clean up the code and make the control flow a bit easier to follow. But before we do this, we'll go through the source code line for line again and describe what's going on here. So we start at the import, and import will pull public symbols from a module into the current scope. So an import statement doesn't have to be on the global scope, so you can import it inside a function. And you don't have to pull in every symbol as we do here. We can specify the symbols we wish to import. Another thing about imports, or actually about modules, is that they closely resemble the actual file system. So every part before the final dot is a path, file system path, and the final name is a file name. So if you have a.b.c.d.e, this is some file system directory a, b, c, d, e.d, where e is the module. And it's common to only import what you need, but for small programs as this we just pull in everything. We might fix this later on when we're cleaning up the code, because we have stuff like kun that's used one place down here, and you have random that's used one place here, and it's not necessary to have the symbols polluting the global scope here. Next we see the main function, and I might have stated previously that this is the main entry point for our application, and that is logically correct, but not quite, because D uses a runtime library in order to support some of the features. And you might see that you have void main, but every program needs to return an exit code to the operating system, and void cannot return anything. So what's actually happening is that the runtime has the entry point for the application, and the runtime will run all module constructors for every module we are using, and it will also handle returning the correct error code if we choose not to do it. So here we are saying void, so we choose not to return an error code. So when we say return, this will become an error code 0, or return code 0, because 0 is success. And likewise, if we just fall out of scope with no error, fall out of the main function, that is also a success. If for some reason we throw an exception or cancel the application or something, we will get an error code. So we can check this. So we'll build the application, and run it first without success. and you see error code 0, and we cancel it, and we see 130. 130 is you pressed Control C to abort the application. So this makes programs a bit simpler to implement, but you can specify a return type of integer and return error codes yourself, so that might be useful for many circumstances. And next we look at our configuration of the interval. We have been using an enum, and an enum is a compile time constant. The symbols only exists at compile time, and every occurrence of the symbol will be replaced by the expression on the right hand side. So this will be replaced by this. And the same is true if we have complex expressions. It will be replaced like that. So a good example that comes up in the forums every now and then is the compile time regex functionality. And D has some very powerful metaprogramming features that allows you to compile a regular expression at compile time, and it's by far the fastest implementation in existence as far as I know. And I might not remember the exact syntax, but something like this, I think. And the problem here is that you are using an enum, and thus if you have a function call where you use the regular expression, it would be replaced by this expression, and this expression is very heavy to compile, so suddenly your compile speeds are very low. And in those cases you should use immutable. So when to use immutable, when to use enum, you have to think about each case. So immutable creates a symbol that exists on runtime that cannot be changed, but it's one instance, while enum replaces every occurrence of the symbol with the expression. Also, enum are inferring the types, so this is the same as stating that it's an enum of int, and that should compile just fine. And the common expression here, you could also state enum min and enum max like this. So it's a shorthand. The enums come in another flavor too, as a block. So you can have a block like this. And it's the same behavior. It's an anonymous enumeration type. And you can specify the type explicitly if you wish. And you see, when using a block enum, you have to specify the type with colon after the enum. And you might also, these are anonymous, so these symbols are placed into the parent scope. But you could call this enum a value, and then you have to use this scope for the name lookup. And as I said, with the compile time regex and stuff, there is no reason to just use integers or floating points, or you can use strings, you can use structs, or anything that is able to be interpreted at compile time. Next we are generating our random answer, and as with enum, this is inferring the type of result from the expression on the right hand side. And immutable means that no one can change this variable whatsoever. You're not allowed to escape the immutable. And this might not be very important for simple value types that are copied around anyway, but for reference types or aggregated types that includes references again to other types, it is very convenient to have the immutable specifier. And being immutable, that no one can ever change it, that also means that you don't have to lock on reading because it cannot change. So it's very convenient also when doing concurrent programming. And every variable is stored as a thread local variable in D, but immutable values, as they can never change, are can be stored at the global scope, and no locking necessary. So immutable is very convenient for the places you can use it. It is very strict, so it might be very difficult to use at times, but if you're able, you should use immutable. And so we have our call to uniform that will return a value, and you see this syntax tells us that we are supplying a template argument, and every template argument has to be valid at compile time. And here we are specifying the opening and closing, inclusion, exclusion. So uniform will generate code for us that will check or that will generate or value within these bounds. And this is really a shorthand for this. So the template arguments are exclamation point and then parentheses with all the arguments, and then if it's a method or function, it's parentheses and the function arguments. But if we only have a single argument we're passing into a template, we can omit the parentheses. Next, we use formatted write to write our answer, to write our instruction to the user. And then we have a debug block, or in this case it's just a simple single statement, but it could be a block too. And these are very convenient then when you are debugging code or testing code that you don't want to ship in the final application. And logging is very important here, and it's also a way to get around purity issues, because functions in D can be pure, and this means that it's not allowed to write any global variables, or it's not allowed to change the world. So you can't do logging within a pure function. You can't do write line within a pure function. But using a debug block, you are allowed to use this write line. So it makes debugging quite a lot simpler. And then we have our main logic, where we are taking the guess from the user and checking if it's valid and stuff. And we have inside the infinite loop, we have a try block that only catches the convert exception. We have immutable again, that will first read input from the standard input. Then it will strip the left and right hand side of any white space, and then we convert it to an integer. And this is the call that might fail, and the call we are catching. So readline could fail too, but we don't care about that. And then we have the logic to see if it's a valid input and if we are winning the game. And that's the application as we have it now. And what we'd like to do now is to have a limited number of tries to guess the answer. So we can have say 3 guesses, and we can loop over these guesses, so we can for each tries in, for instance, and this will give you up to 3 tries before failing, but we need to break out of this inner loop, and the only way we are breaking out of the inner loop at this time is by the return value here. So we need to break out of the inner infinite loop reading inputs, and break will break out of the closest loop and put us here, and we'll get up to 4 each again and continue trying. So let's see if this works, and we lose. So that's good. We are able to lose the game. And so the question, where should we put our message of losing? And we could do it here. If tries, max tries, you lose. And of course we need to break out if we lose. And now we are at a place where we can start changing the application and cleaning it up, because there are many problems with the current application. For one, we have 2 loops, 1 inner loop, and we have all the code within a single try-catch block, and we have nested ifs, so we have a loop within a loop, or we have an if within an if within a loop within a loop, and we have early returns several places, and we have a break out of the inner loop, and this code is really difficult to understand. The control flow is spread around everywhere, and it's jumping around, and it's really difficult to understand. And if you look at this code only a week from now, you'll probably have some difficulties reading it. So let's see where we can start to extract code. And looking at the infinite block here, we see that what it does is reading a value from the user, and it will continue to read until it gets a valid integer, and it will write guess each time. And this is a good place to start and just pull out this code. So we can implement okay, looks like some plugin have gone wrong here, but anyway. So we'll read input, or we can call it read inputs. And we have our while block. And we can copy this stuff up for the time being. Let's see. Yeah, we don't actually have to use let's not delete the old code just yet. So what we do is actually just return the valid integer we find. And if it's not valid, we will write a message saying that's not a valid number, and just continue. And when we have stuff like this, we have a return in the inner try here, but there are no other ways to return from this function. So we might state this in D. D includes assertions, and that is code that must always hold true. So if it's false, it will generate an exception, and your program will fail. So it's a very valuable debugging tool to write code that will crash early on if there is some problem with the state of the application. And if you write some expression that is always false, like 0 or false, it will not be compiled out when you compile release mode, a release mode build. So this will be there in release mode too. And that's okay, because if this one is triggered, then we have something seriously wrong in our application, because it shouldn't ever get to this line. We return here, we don't have any breaks, we have an infinite loop, so there is no possible way it should exit by getting to this line. And I see I have like this. And now we can remove the entire try catch block. Let's see. So this isn't, guess it's not a number, this isn't necessary anymore. And we can say mutable guess equals read int instead. So we were able to remove the entire try block, and I still see that we have the while here, and that's not correct. So let's think about this. This will loop until we get a valid number from the user. and it will return, and we have to change this line because we don't want to break anymore if we get a wrong answer, no, wrong guess. So let's test this. Read int, did you mean read input? I probably did. Okay, so let's test. And it's working as expected here. And so we still have the return here and the inner ifs here, and let's see if we can do something about this. So we can at least pull this one up. A bit better. And I see I have introduced a bug while refactoring here, and that is here, where we are checking if guess is in the range we are trying, or inside the valid range. And the problem here, if the guess is outside the range, we shouldn't actually use a try on that, because we have the instructions on the top, and it's just a silly mistake if the user does this. So we need to pull this one into the read input function too, and that means that we have to supply the values so that we can actually do this check. So this should do the trick. And I've got to add the arguments here. Int min, int max. And we should call this min and max, because it's no longer constants for us. Min and max. Okay, and this should probably fix it. Outside the range, 10 is a yay, and too many tries fails. So the program works as expected right now, at least. We can do the same thing down here as we did in our function above. Add a control statement here and an assertion at the bottom level. This way we have a simple string of if-elses, and we have the control flow at the end of each if-else. So this makes it a bit easier. So you have if you have won, if you have failed, or else if you just have the wrong answer, and you have the control flow at each level here. We also notice that while we should never get here because of the control flow inside the ifs and else ifs, we also should never get to this point, because we should always hit one of these returns. And there's one more thing that is bugging me, and that is that you don't get an information on how many tries you have left. So we could run max tries, minus tries, We can use for each the reverse to go through the lists, or we can use an iota with a negative step, or we can use a simple for block for statement. So we'll just use a simple for block now. So tries left is max tries while it's greater than 0. And as I said, this can be done several different ways, but this should also work. So wrong answer, tries left, try again, and we have the tries left, and we have to state right line, formatted right. But again, we don't have to use this. So sometimes, like here, it might be clearer to use this syntax. So wrong answer, tries left, try again. Let's see this. And we should never break out of this loop, as we stated earlier. And one thing here is that this is for C programmers. If you have been coding in C, you might be used to writing Yoda expressions instead, if 0 equals tries left, because if you write this wrong, you'll get an error stating that you cannot assign 0 to a value. This in C, on the other hand, would assign the tries left to 0 and then check the value. So if we had some other value, this would be true even though we meant if it's equals to 1, this one will always be true. But in D, we get an error, as we see here. Assignments cannot be used as conditions. So this has been a quite long tutorial, but we were able to fix up the application a bit, and it should hopefully have a bit better control flow now than we had when we started the application. A bit simpler to understand, not as many levels. So we'll call it the day. Thanks for listening. Bye.